Welcome to Erin channel and welcome back to the screw thread course. So far we've made a bolt and we've made a nut, and this just showed us the basic principles of how to make male and female screw threads. But up until now, we've just been following along with the suggested dimensions of this video. But what if we want to make a screw thread of a different size? Because chances are that we won't want one the exact same size as this one. In this video, we're going to have a look at how we can make any thread size we want, and standard thread profiles. Luckily, there's hundreds, if not thousands, of standard screw thread sizes, and we can easily find this online by searching for things like screw thread profile. And I'll show you an example now of a really good resource that we can use. So this is a lot of screw threads from a website called Maryland Metrics, mdmetric.com. And if we can't access the website for any reason, we can also find this as a PDF to download in the course downloads on the description box below. So this is a table of all different standard thread sizes, and we can see as we go down, there's literally hundreds of them. So we have the name here on the left, M4x5 for example, and as we go down we can see that the size increases. And we'll talk a little bit about what these numbers mean in a moment. If we go back all the way to the top and we have a look at a little diagram, this is actually the thread profile that we are going to draw. So we have the bolt and the nut, and all of these numbers and letters and equations all relate to different things within the table below, and it looks pretty complicated and daunting, but there is actually fairly simple once we get down to making the thread. So when we are making our thread, the first thing that we need to do is choose the rough size, and then we can look down here through all the names of the thread, and we can find one which will be suitable. So all of our threads for metric will be called something like this. For example, M10x1. So what this actually means is that an M10 bolt will fit through, and this is a bolt with an outer diameter of 10 millimeters. So that's the first half of the number, M10x1. And then the second number, the 1, indicates the pitch size. This tells the distance between each thread. So 1 just means that there is 1 millimeter between each thread. So obviously a larger number here indicates a coarser thread. So we could have M10x2, M10x1.5, and so on, and all different sizes. Then all of the other numbers in the table actually relate to different parts of the drawing at the top. To show how this works, we'll use this to create an M10x1 thread. And then we can use exactly the same process to make pretty much any thread size we want. This table here goes all the way up to M600, which is absolutely massive, probably too big for most printers to print. And they go all the way down to M0.25, which is absolutely tiny. So let's go back to Solidworks, and we'll use this data to start some new parts. Start a new document and choose part. And then we're going to draw the bolt shaft first on the top plane. So make a sketch on the top plane and just draw a circle. And the first thing we need to do is figure out which bolt diameter to use. So if we look back to our table and we look at the bolt, which is this section here, you can see that we've got the major diameter, the pitch diameter, and the minor diameter. And each of these sections has two numbers, which is an upper and lower limit for tolerances. And this is because we can actually only make things to a certain accuracy. So as long as we make a bolt within those two numbers, it should fit the corresponding nut correctly. So first let's look at the minor diameter. So the minimum of that is 8.596 millimeters. But for 3D printing, there's no way we are going to get anywhere near that sort of accuracy. So just drop it down to one single decimal place. So let's call that 8.6 when we round off that number. So the minimum diameter of our bolt, T3, which relates to this drawing, is going to be 8.6. So let's make our bolt shaft slightly smaller than this. Let's make it 8.5 millimeters. So draw our circle fixed to the origin. Make it 8.5 millimeters. And then let's do a boss extrude. And extrude this 50 millimeters. But obviously we can make this any length that we want. And then when that feature is created, just rename it as something like a bolt shaft. And this is a good point to save our bar. So following the exact same process as the bolt that we made earlier, the next thing we need to do is create a helix. So start a sketch on this bottom face. We can add the bolt head later on. and then go to a normal to view. Let's draw a circle to base the helix on. The first thing we need to do is figure out the pitch diameter. So if we look at the thread table, we can see that the pitch diameter D2 should be between 9.3 and 9.2. So for the bolt, we'll go with the lower end of the tolerances. So we'll go with 9.2. If we make the bolt at the smaller end of the tolerances and the nut at the larger end of the tolerances, they should fit together a little bit better. Then from within this sketch, we can use this circle to make the helix. So go to the Features tab, Curves, Helix and Spiral. We need to set the following settings. So the pitch is 1 because it's M10 by 1. Then we may need to reverse our direction, so we're going up the shaft. Then set the revolutions as 48. So we are not going all the way to the end of the shaft, but most of the way along it. Set the start angle to 0, and then set the direction as counterclockwise, because it's going to be a right-hand thread. Then press OK and our helix will be created. Next, we need to draw the thread profile itself. So select the appropriate plane. We can see here this is the start of the helix. So if I hover over the planes, you can see for me it's the right plane. So start a sketch on the right plane, and then go to a normal to view. And if we zoom in, we can see that the helix is slightly larger than the bolt shaft. The first thing we are going to do is add a center line. So zoom out so we can see our whole model, and then from the line tool, press the drop down and choose center line. And then just add a center line, start at the origin, and going vertically all the way up to the end of the shaft. Press escape to exit the line tool, and then zoom back into the bottom. And basically we are going to draw the thread profile down here in the right hand bottom corner. Select the center line tool again by going to the line tool, then pressing on the little arrow, and hover over at the bottom edge of the shaft. So we've got the coincidence symbol, and we just need to draw a triangle. So firstly draw a vertical line down, then draw another line up into the right, and try to pick up this snap point. So that means at the end of our line is in line with the midpoint of that vertical line. Left click again and then go back to the start point. And left click again to close the triangle. And then we can either double click to exit drawing segments, or we can press escape to exit the line tool. Then select the center line again, and this time we want to draw a line from the right hand point of the triangle all the way over to the midpoint of that vertical line. And this should be a horizontal line if we picked up the midpoint snap. If not, it might be slightly off horizontal. Just draw it from the right hand point over to the midpoint of that vertical line. Then after we've drawn it, click on it and it should be horizontal. And if it's not, if we don't see the little horizontal symbol, just click on make horizontal from the menu that pops up. And that just means that both sides of our triangle will be symmetrical. But if you drag out one side or change the dimensions, that will be mirrored on the other side. We are now going to use this triangle as a guide to draw our thread profile. So first we need to set it at the correct diameter. Select the point tool, then add a point to the midpoint of that horizontal line. Should be about here. Then select the Smart Dimension tool, and we'll dimension from this point. So click on it to the center line. So click the center line, and then before we make our final click, just move our mouse around a little bit. And we should see that on the right hand side of the center line we get one dimension. But if we move over to the left, the dimension is actually doubled. And this gives us the full diameter. Go to the left hand side and click to place the dimension. And then we want to add the same dimension as the pitch. So that's 9.2 millimeters. And now we should see that the middle of the triangle is in line with the helix. We could have added a dimension in directly to the helix. That can be a bit difficult to pick at that start point exactly sometimes. Then let's add some more dimensions. To get the Smart Dimension tool, if it's not still open. And then firstly we'll set the pitch as 1 mm. So this vertical line needs to be 1 mm. Then the angle between these two lines of the triangle should be 60 degrees. And we should see our triangle moves out like this. And this is the basis for our thread. So all we really need to do is draw over these construction lines to draw our thread profile, and then sweep it along the helix. To do this, select the line tool and we'll start drawing over the triangle. Start from the top left and go directly down. And instead of following the triangle straight away, go out to the right horizontally a small amount, and then go up to the triangle line. Then follow along the triangle, not right to the point, and then go up to the next line, and then go diagonally up to the left, and then just try and copy what we did at the bottom. And we should have a profile something like this. It doesn't matter at this stage if it's not exactly even, because we're going to add relations and dimensions next. Firstly, let's add the outer diameter of this top section. If you look at the thread profile, this doesn't actually go to a point. It's actually slightly flattened off. So select the Smart Dimension tool, click on the outer line, then click on the center line, and move over to the left, and left click to add in the diameter. So looking back at the drawing, this should be D, which is between 9.9 and 9.7 millimeters. And if you look up, we can round up that 9.7 to 9.8. So just add in that dimension, 9.8 millimeters. And then for this inner diameter or the minor diameter, we want to add a similar thing. So click on the line. And we might need to click on the center line again, but our dimension might just pop up like this. So this should be between 8.89 and 8.56. So let's add 8.6. And we might see that our sketch is still underdefined, because this top line isn't yet defined. To fix this, we can select this small vertical line, hold down Ctrl, and then select the top counterpart, and then add a collinear relation. And that will make these two lines exactly lined up. So now our sketch should be fully defined. And if we look at the actual shaft size and the thread profile size, we can see there's gonna be a bit of an overlap. So we're gonna fill in that gap that we had earlier. The last thing we need to do is add the fillets to the bottom edge of the thread profile. And if we look at the drawing, we can see from this equation at the top that R, the radius here, should be P times 0.144 and so on. But we don't need such an accurate figure here, so we can actually choose the sketch fillet feature, and we can type this equation directly into work out the size that we need. For this size, it's fairly simple, because it's just a 1mm pitch. But if it was a different size pitch, then the math might not be quite as easy. So we can just type it down here, 0.14 times, and then the pitch, which is 1mm. And that should give us the correct amount, which is 0.14. So we can click to add this to these two small corners. But we might find that we can't actually add this fillet, and that's because it's slightly too large for the corners. And if this happens, we can just round the number down slightly. So let's try to rounding down to 0.13. And then try adding it. And now we can see that we can add the radius correctly. Now our thread profile is complete and the sketch is fully defined, so we can exit the sketch. And then select the helix, hold down Ctrl, select the sketch, and then go to Swipe Boss Base. And then we should get a preview something like this. Press OK, and our thread will be created. Now if we look at our thread profile, we can see this looks a lot more like a real bolt compared to our first example. And then finally we could just start a sketch on this bottom face. And then just quickly add in a bolt head using the polygon tool. There are actually standard bolt head sizes, but for now we'll just do it by eye. So we'll go with 14mm across the flats and extrude it 5mm. So there we have our bolt, and we could add some more finishing touches, but instead we'll save the bolt and then we'll go directly onto the nut part. Start a new part, and firstly we'll draw the nut profile on the top plane. So draw the outer using the polygon tool, We'll set this the same size as the bolt head, which is 14mm across the flat. Then add a vertical relation to fully define the sketch. Next, we need to figure out the size of the hole within the nut. And we can do this by looking at the table. The furthest thing column is actually called tap drill size, and this indicates the size of a hole that we drill before we actually cut the thread into it. So this is a good starting point for the middle of our nut. So let's draw a circle fixed to the origin and 9mm diameter. Then we can extrude this nut profile upwards, and we'll extrude it 8mm just to make it a little bit thicker so we can see the thread clearly. Then rename that feature, and we'll follow the same process that we made the original nut with. Spin our model over and start a sketch on the other side face. And firstly, we are going to draw a circle which the helix will be based on. So use the circle tool to draw this circle fixed to the origin. And we'll set the dimension based on the pitch diameter in the table. And take note that this is slightly different to the pitch diameter of the bolt. So in the table, this is between 9.35 and 9.5mm. So we'll go with 9.5, just so we can use the higher end of the tolerance. Then we'll use this circle to create a helix. So go to the Features tab, Curves, Helix and Spiral. Then let's keep the pitch as 1, so the pitch should always be the same for the nut and the bolt. We can reduce the number of revolutions down to maybe 10, so this makes sure it goes all the way through the nut. Start angle should be 0 still, and we can change the direction of the thread to clockwise. Then press OK to create the helix. Next, we need to draw the path itself, so find the start of the helix and start a sketch on the plane that cuts through this. So for me, this is the right plane. Then go normal to, and we're going to follow quite a similar process to what we did with the bolt. So firstly, we'll add a center line down the middle of the bolt, going from the origin directly vertical to the top of the nut. Then we'll use some more center lines to draw a triangle in the same way that we did with the bolt. So this should start coincident from the bottom edge of the nut. Go directly down, up and to the right until we get that midpoint snap, and then up to the left to close the triangle. Then add another line going horizontally across the middle, just to ensure that our triangle is symmetrical. Next, select the point tool and add a point to the midpoint of that horizontal line. Then add a dimension to this point and to the main center line to set the position of this triangle. So this should be the same as the pitch of the helix that we just drew, so that's 9.5mm. Then we can add some more dimensions, so the pitch or the actual height of the triangle is 1mm. And then the angle between the two edges is 60 degrees. If we look from this view, it can actually be a bit confusing, because it might look like this is the hole. If you zoom out, it's actually just the edge of one of the flat faces. If we were to go to a cross-section view, we can see that the triangle actually cuts directly into the inner hole. Now let's follow a similar process to the nut. So all we have to do is select the line tool, and then basically throw the thread cut profile over these triangle construction lines. So start from the top left, go directly down, and then throw the same profile as we see in the video. Make sure we don't go all the way to the point. And then when we are finished, we can start to add some dimensions in. The first one can be the largest one, which is the major diameter. So it's between 10 and 10.924. So let's round that to 10.3. And if we zoom in, we can see we've taken off the very point of the thread cut there. Next, we can do the inner diameter or the minor diameter. So it's between 8.9 and 9.153. So again, we'll round this one up to 9.2. Then we can exit the dimension tool by pressing escape. And we can just select that small vertical line, hold on Ctrl and select the line above it. And then make those two lines collinear. And then should make our sketch fully defined. We can then exit that sketch and we can use a swipe cut. So select the helix, hold down Ctrl and select the sketch and press swipe cut. And then we should get the yellow preview as usual. And then press OK to create the feature. So there's our nut. And if we go to the top view, we might remember when we made the first nut that the hole looked really uneven. And if we look at this one, it still is slightly uneven just because of the nature of the helix. But this one looks much more in proportion, so we can save the nut part. And then finally we'll just add the nut and the bolt into an assembly, so we can have a check that they fit together properly. Press Ctrl Tab to go back to our bolt part, and then we'll go to File, Make Assembly from Part. Make sure we've got the bolt selected. Press the green tick and the bolt will be inserted fixed to the origin. Then next go to Assembly, Insert Components, and insert the nut, and just place it somewhere near bolt. Then we can use mates, so we'll select a circular face inside the nut. Hold down Ctrl, and select the circular shaft of the bolt, and add a concentric mate. Then we can also add a parallel mate between one of the flat faces on the nut and one of the flat faces on the bolt. And this will just stop the nut rotating as we drag it up and down the bolt to check the fit. Then go to a front view and a cross-section view. And if we zoom in a bit, we should be able to find a position where the nut and the bolt are clear of each other. We then exit the cross-section, click on the nut and make it transparent. We should be able to see that the threads of the nut and the bolt line up correctly. If we do see a clash here, then just open the nut part and edit the helix, and adjust the direction of the helix. And if we are happy with that, click on the nut again and make it solid, then go to another cross-section view, and zoom in a bit. And we'll have a look at its tolerance. If we got the measure tool from the Evaluate tab, and we can measure between these two threads, and what we probably find is that they're very close together. About 1/10 of a millimeter. As we mentioned in one of the previous videos, these parts will probably be too tight to fit together unless we have got a very accurate printer. So ideally, depending on our printer, all of these gaps should be about 1/2 millimeter. So what we'd have to do in this case is actually adjust thread sizes a bit. So maybe make the profile on the nut slightly larger and the profile of the teeth slightly smaller, as long as they still mesh together. Now if we go back to our bolt part, and we expand the thread profile sketch, we should be able to see that we can now actually use this basic layout, especially this triangle with a 60-degree angle and the height which is the pitch. We can use this triangle to make an appropriate thread which would work with our printer. So to very quickly recap, first we just made the shaft. Next we draw a helix with a diameter the same as the pitch diameter of the bolt. Then we drew the triangle shape from the thread profile. We added in the correct dimensions. And then we drew the actual thread profile over that. And we added in the minor and major diameters. Then we used this thread profile to make a swipe post base, which is the actual thread itself. And then finally we just added the bolt head as a simple extrude. Then with the nut we did a very similar thing. First we just drew the nut body. And the hole down the middle is actually the top drill size from the thread table. Then we added a helix, again using the pitch diameter from the thread table, and then we drew the actual thread cut profile itself, and we did a swipe cut to cut this into inside of the nut. So hopefully this video explained a little bit about the thread profiles, set us up well to make any size we want. In the next video we are just going to have a quick look at some final finishing touches, including a more advanced way to finish off our thread on our bolt. Thank you for watching, please subscribe if you like, hope it can be a little helpful and useful.